Alright guys, so we're going to go ahead and talk about composition of functions. Here's an example I have where it says my f of x equals x squared plus 3x plus 4. It's a trinomial. And my g of x equals x plus 1. Right here underneath it, I have written what most people that I know that does math just calls this fog, but it's actually read f composed g of x. And what this actually means is that you're going to do f of g of x. Now what's really, really nice is that this g of x, we already know what it equals. It equals x plus 1. So we can do the substitution, just substitute it in, and we get f of x plus 1. Now, the x plus 1, what this is going to do, what you have to do with this right here, is everywhere that there's an x in my f of x, I need to replace the x with x plus 1. Well, my f of x is x squared plus 3x plus 4. So when I go ahead and replace it, I end up getting, open parenthesis, x plus 1 squared, because this originally, sorry about that, I hit next page. This part originally, that originally was my x from right here. I replaced that x with the x plus 1. Now I'm going to do plus 3 times x plus 1 plus 4. Now you're not allowed to leave it like this. You need to go ahead and simplify it. So you'd want to go ahead and FOIL the x plus 1 squared or do the box method. I don't care as long as you get the right answer. When you do that, you end up getting x squared plus 2x plus 1. Of course, then we do plus, distribute your 3. We get 3x plus 3 plus 4. From here, we combine like terms, and we'll end up getting x squared plus 5x, because we have 2x plus 3x. And that leaves us 1 plus 3 plus 4, which gives me a positive 8. So, f composed g of x equals x squared plus 5x plus 8. Now we're going to work a different example, just kind of looking at it differently. We are going to do g compose f of x. That is, we're going to do g of f of x. Now, what this means is that my f of x is going to go inside, so it's g of f of x. Well, from here I replace my f of x with the original f of x, which is x squared plus 3x plus 4. So this becomes g of x squared plus 3x plus 4. And everywhere there is an x in my g of x, I'm going to replace with x squared plus 3x plus 4. When I do that, I get x squared plus 3x plus 4 plus 1, because originally it was just x plus 1 was my g of x. From here, I'm going to gather my like terms. The parentheses you don't really need. We end up with x squared plus 3x plus 5. So now that we have my f of x and my g of x here, we need to make a generalized statement. Is compositions of functions, the composition of functions commutative? Now, the commutative property, it holds true for addition and subtraction. What that really means is that it doesn't matter what order you add in. You could do 2 plus 2, or 2 plus 3 is the same thing as 3 plus 2, or 2 times 3 is the same thing as 3 times 2. But for this to be commutative, that would have to mean that my f composed of g of x has to equal my g composed f of x always. There never can be a time that it's not. Well, just in this example alone, if we see that f composed g of x is x squared plus 5x plus 8, and g composed of f is x squared plus 3x plus 5, they are not equivalent. Therefore, a composition of functions is not commutative. So the answer to this would be no, it is not commutative. It's really important that you understand that f composed g of x and g composed f of x, you can have the same two functions and not get the same answer. Sometimes it happens. Sometimes they only equal x, and that's something special that happens. We'll talk about that later on. But the process itself, pretty straightforward, but you need to understand that the composition of functions are not commutative.